We started sort of referring to this, our topic for today, yesterday, when we were doing our electron dot diagrams, and we talked a little bit about the electrons and atoms wanting to become stable. And so that's going to lead us today into our discussion of compounds. So basically, everything we've been talking about so far was about individual elements and atoms. But we know that's only part of the picture here in chemistry, because atoms join together and form compounds all the time. So that's what we're going to talk about today. Can you give me an example of a compound? Okay. Water. What is it made of? Hydrogen and oxygen. It's made of two elements. Give me another one, Wyatt. Salt. What's it made out of? Sodium and chlorine. Two elements. Jake?
Glucose.
Glucose. Made of three elements. Carbon, hydrogen, oxygen. Good. What are the numbers like H2O, CO2, C6H12O6? What are those numbers then referring to, Layla? Not so much, not how many protons. Will?
Carbon, hydrogen, and oxygen.
Yeah, but I want to know when we say C6H12O6. What do the numbers mean? Well, that's what I'm saying. Why is it C6? No? Olivia? Yeah. So how many atoms of each element make glucose? So in glucose, you need 6 carbons, you need 12 hydrogens, and you need 6 oxygens, C6H12O6. And they're all what we call bonded together. They're all forming one molecule of glucose. Mitchell? They won't form that. They won't form glucose as we know. There are other, there's, CH4 is methane. So if you have different numbers, you have different compounds. All right. So why do certain elements bond with other elements at certain times? Well, first off, all compounds sort of want to become stable. All elements, all atoms want to be stable. And for the most part, now there's exceptions to these rules. We're taking a very simplified view of chemistry here. So when you take chemistry maybe in 10th grade, you're going to learn a lot more detail about these things. You probably say, well, what we learned in 8th grade, that wasn't really 100% correct. We're simplifying things a lot. So usually what it means to be stable is to have a full outer shell of electrons. And for most atoms, that means 8 in the outer shell. Most of the energy levels are full when they contain 8 electrons. So most atoms don't have 8. Remember which ones do have 8? What? The noble gases in the far right of your periodic. They do have 8 in their outer layer. They're happy the way they are. Remember, they don't need someone else to make them happy. They're fine being alone. So most atoms, like we said, don't have 8. They might have 7 or 6 or 1 or 3 or 5. And so in order to get to 8, they might want to gain or lose electrons. And so we have this rule we call the octet rule. The octet rule says that atoms will form compounds in order to reach a full outer shell, in order to reach 8 electrons. And they will typically do that the easiest way to think of it. So, if you have an element that has 3 electrons in its outer shell, what's the easiest way for it to get a full outer shell? To get rid of those 3. Send them to somewhere else. And then those 3 will be gone, and the next level below it will be full. What if something has 7? What's easiest? Get 1. To gain 1 more, and that would give them 8. So atoms with less than 4 electrons tend to lose electrons. Atoms with more than 4 electrons to gain electrons. Then they can do either one. Sometimes they gain 4, sometimes they lose 4. Just sort of depends on what they're going to be bonding. Yeah, that's good, right? Yeah, they could. All right, so atoms want to have 8 electrons in their outermost shell. That is the octet rule. So we can show this using these electron dot diagrams. How many electrons does hydrogen have in its outermost shell? Just one. Oxygen, anyone remember? 6. So here are my hydrogens. They each have 1 electron in their outermost shell. What about oxygen has 6? 1, 2, 3, 4, 5, 6. So hydrogen. Look at some other element in your periodic table with a lot of electrons. Look at sodium, for example. How many electrons can the very first shell hold? It only holds 2. Okay. The first electron level only holds 2. So hydrogen has 1. What would it like to have? 2. So it shares an electron with oxygen. How many does this hydrogen have now? It has 2. This hydrogen also shares 1 with oxygen. It's happy. It has 2. What about this oxygen? It has 2, 4. It's sharing this one. 6. How many? Is it happy? Yes. And these 3 atoms have formed a bond. They're bonded together. And what do we get? What is it called? Water. H2O. Okay. Let's look at another example. Sodium. How many electrons in sodium's outer level?
1.
Just 1. Chlorine? 7. What are they going to do?
4.
Yeah. Okay. In this case, sodium is going to actually give away this electron. Say, I don't want it. Sodium gives it away. Says, chlorine, you take this. So, sodium has how many? And it's lower, it's layer below that? 8. Chlorine now? 8. Are they both happy?
Yeah.
They are. Carbon and oxygen. Carbon has 4 electrons. Oxygen? 6. They're sharing again. How many does this oxygen have? 8. How many does this oxygen have? How many does this have? It has 4, but it's also sharing these 2 with oxygen. Okay? Yeah, sometimes they give them away, sometimes they share them. All right, so let's just look at this and we'll have a simpler way to actually figure this out. So on this one, shared. So how many does carbon have? 2, 4, 6, 8. They each have 8. Carbon is sharing these 4. Yes, it's sharing these electrons.
Why would it share those? Those are next to it.
It's just the way they're drawn. All right, I'll show you the simpler way to figure these out. Maybe. Did I break this? Oh, no. All right, so remind me, what is the term for the outer shell of electrons? Valence electrons. And remember, everything in one group has the same number of electrons. Everything in group 1 has 1 electron in its outer shell. Group 2 has 2. All right, so boron. has 2 electrons in its first shell, 3 in its second shell. Bromine is 2A18-7. Only these outer electrons are valence electrons. And when atoms are going to form compounds, it's really only these outer electrons that are actually important. These ones don't really interact with other atoms. All right. Now, on your periodic table, you have a list of the electron configuration. Sometimes periodic tables also list something else called the oxidation number. Or it's sometimes called the valence number. And boron has an oxidation number +3. Bromine is -1. Can you, hold on, thinking about the electron configuration, can you infer where does that number come from, Jake?
Because boron has 3 more than its like outermost shell.
Right.
And bromine has 1 less than it needs.
Yeah. So I like to think of it this way. The sign that goes with it is telling you +3, there's 3 extra electrons that boron has that it would love to get rid of because it has 3 in its outer shell. So it's +3, 3 extra electrons. So bromine is -1. That's because for it to be stable, it's missing 1. It's -1.
Oh, so I can count this 5.
All right, so let's look at some examples so that you can understand this and be clear. So, 1 electron in sodium's valence level. What do you think its oxidation number is? You need a sign with an oxidation. Would it be -7 or +1? What does it want to do? Get rid of it. It has 1, what do we say? Extra. It's +1. Look, it has 1 extra electron. It's 1, if it could get rid of that extra electron, it would be happy, right? Because then it would have 8. Let's look at chlorine. It has 7. It's what? Missing 1. If it got that 1, it would go up to 8, and then it would be happy. How about carbon? What do you think is carbon? What could it be? It could be either one. It could be +4, or it could be -4. How about gallium? Just say numbers. Look at it. Minus or plus? So does it have extra or is it missing? Extra. And therefore it's plus. Extra is plus. You guys do this. You guys fill this in as your periodic table.
What's a better way to like
Just gotta look. You'll start to recognize where they are.
I can't.
Take care. Oh, where's Krypton? Got it. No, wait, zero.
How are we doing? Good question. We'll talk about that right now. Oh no. Oh no, that's right.
That's what it needs to be.
All right. So let's go over this. I know, that's why you got to figure out. All right, potassium. Do you have a question? Okay, what? No. All right, potassium. Leo, how many valence electrons does it have? 1. So what is its oxidation number? Leo? Plus 1. It has 1 extra electron that it would love to get rid of. Calcium, Devin, how many valence electrons?
2.
What's its oxidation number? Let's do it. 2 extra electrons. Let's do it. Lead. Maddie? 4. Now this is one of those weird ones. It could be plus or minus 4. Because it's easy, it's just as easy to gain 4 as it is to lose 4. Question over here? Yeah, Krypton. Olivia? I mean Olympia? 8 valence electrons? 0. Forever alone. It's happy alone. It doesn't need any other element. Forever happy alone. All right, phosphorus. Phosphorus. Emma, how many valence electrons, Emma? So what is it, Emma? What's that? -1? No? What does it want to get to? What's it want to get to? Yep, -3. It's missing 3. It has 5. It wants to take the easiest way to get full. The easiest way is to fill in those missing electrons. Because that's, so your oxidation number will never be greater than 4 for our purposes. It's going to be either 4 below, or it's going to be plus or minus, and it's going to be 4 below. All right. Because 8 is full, and a full outer shell is a stable configuration. Yeah, because some energy levels can fill up and hold 16, but it's a it's sort of a strange way that they get filled up. They don't get filled up in order. You'll learn about that. Yes, exactly, and that's true. If it lost them, 16 is full for some. 32 is full for some. It's beyond the scope of what we're going to talk about. But that's a good question. You notice that some of these numbers are higher, 16 or 32. And so that's because they hold different numbers. All right. Metals and nonmetals. So metals and nonmetals in terms of chemistry are maybe a little different than you imagine them in your everyday use of the word. So in chemistry, metals are the elements that have less than 4 electrons in their outer shell. Nonmetals, then, are those elements that have more than 4. Where do you find the metals? On the periodic table? Where do you find metals? Well, not top up, but left in general. Left side of the periodic table. And non-metals are on the right side of the periodic table. Metals, because they have 1, 2, or 3 electrons, to become stable, they want to lose those extra electrons. What do non-metals want to do? Gain missing electrons. Yeah, good question. Talk about it. Metals have a positive oxidation number because they have extra electrons. Non-metals, finish my sentence. Have a negative because they're missing electrons. All right. Now we got some terms here that you may not be familiar with, but I will explain them. The characteristics of metals. If I ask you what is a characteristic of a metal, what are some descriptions you might use?
Less than 4.
Well, I'm saying just in your, like, if I can show you a metal, what does that mean?
It's like 30. Like
30?
It's not flimsy.
Okay, I guess I'm going to get to something similar. Okay? Okay, why? Oh, hold on. None of these things are really. All right, Maya. Shiny.
Well, I guess it is if it's not old.
They're good conductors. What does that mean if something is a good conductor? It conducts electricity. Metals can conduct electricity, or they can conduct heat. They are malleable. That means you can hammer them into a shape. They are ductile. You could stretch them out into a wire. Computers all use gold wires. Yep. Non-metals are sort of the opposite. They're not malleable. They're not ductile. They're brittle. You took a chunk of sulfur and tried to hammer it into a sword. It would just break apart. It's brittle. It wouldn't bend into a certain shape. They're not good conductors of heat or electricity.
What about diamond wires?
No.
Yeah. Yes. Yes. Oh yeah, it might be one of those outliers. Good point there. So there are some things that are on this staircase here that are called metalloids. And again, they might not agree 100% with the rules we just talked about. That was sort of in general. And things that are in that staircase, we call them metalloids. It means they have certain properties that are metal-like and others that are non-metal-like. All right, we are going to cancel your homework.
Yay!
Yes!
You're so good at canceling homework. It's so fun.